Hey guys, so we're back again. We're going to talk about section 15.2, which is something called trapezoids. I'm noticing that my document camera is trying to zoom a little bit more than I want it to at times, so things might get fuzzy. Bear with me. It's what we've got to work with. Sometimes it's good, sometimes it's not. Here we go. So we're going to talk about trapezoids. Trapezoids are another special type of quadrilaterals. And there's a good bit of stuff going on with these. So I've got two poorly drawn trapezoids here. What's special about a trapezoid, and I'm going to kind of pull up my handy dandy flow chart that we had in our intro. And again, this is going to be located in Google Classroom. You'll have everything that you need. So on this one, on a trapezoid, we have a pair of parallel sides. And those parallel sides are what we call bases, which is kind of handy. The median is half the sum of the bases. The adjacent angles along the leg are supplementary. Then there's a special type of isosceles trapezoid. So I promise I'm going to help you understand all of that as we go through this. We're going to try to do a lot of different examples. But in this first trapezoid, I'm going to label the bases with the parallels. Now, admittedly, in your assignment, the parallels are not going to be put on there. But if it looks parallel, it's going to be parallel. So those are what we call the bases. So I'm going to label each one as a base. On this other trapezoid, these two are each going to be a base. And then we have adjacent angles along the leg are supplementary. So I want to walk you guys through what that means. If we're looking at legs, these other two sides are what we call the leg. So this angle up here on the top and this angle down here, and I'm going to label A and B. If we take the measure of angle A plus the measure of angle B, they're supplementary. They're going to be 180 degrees. And then if I do the same thing for angle C and angle D, the measure of angle C plus the measure of angle D, those are also going to be supplementary. So that's what that means when it says, oops, you can't see that. Zoom, baby, zoom. Come on. Oh dear. Well, maybe if I write more, it'll zoom in better. Hey, it worked. So, oh, it's still happy. Good. Adjacent angles along the leg are supplementary. That's what this means. Along the leg, supplementary, which is kind of nice. So the other thing is talking about the median. Well, on the median, remember a median, cut something in half. The median is if we find the midpoint of the two legs. This median, and actually I'm going to draw you guys another one just so I don't have so much going on. Pretend I nailed that perfectly. This median, so it's cutting these two, those two. It's theoretically cutting things in half. Not the way I drew it, but you know, it's supposed to be way better than my picture. The median is half the sum of the bases. So I'm going to put my base on the top and my base on the bottom. The median is equal to half of each base added together. So I'm going to label this as base 1 and base 2, base 1 and base 2. And that's going to be the same for this special guy as well. This guy is an isosceles trapezoid. So what that means is that the left leg and the right leg, they're congruent. And in an isosceles trapezoid, the base angles match each other. So these two guys on the top are congruent, these two on the bottom are congruent to each other. Oh, please focus. Sorry, I don't have any control. This is the only equipment I have, and as you can tell, it's annoying me. Yesterday, the only way to get to work was to hit it. Maybe it has a concussion. Oops. So those are kind of the characteristics, and that's what's being summarized here. I know I went through that quickly, but remember, you can pause and go back and listen to my lovely voice over and over and over again. So let's start walking through some of the examples that we have in our assignment. Remember, I'm going to be doing the evens, you guys are going to be doing the odds. So right here we've got a trapezoid. Parallel, parallel, base, base. So we need to find the length of the angle indicated. Well, guys, these two are along the leg. The leg angles are supplementary. So I'm going to name I'm just going to go with my question mark. 92 plus question mark equals 180 degrees because the angles of the legs are supplementary. Okay, that's kind of cool. Subtract off our 92, and I believe our question mark becomes 88 degrees. Let's jump ahead to number 4. So we now have an isosceles triangle, and I can tell you that because these two legs are marked as congruent. So I'm going to put the word isosceles in here. Well, there's my two bases, my parallels, and we need to find this x. Okay, we got to work our way to that x. Remember that the base angles, the angles along the parallel side of an isosceles triangles, are congruent. So these two guys are 70. That then allows us to work with the leg angles. The leg angles add together to be 180. So that means that our question mark is 110 degrees. Okay, so that's kind of playing with angles in those examples. I actually am going to keep on going through our assignment, but there's some more with angles that are coming your way, in particular like on number 16. But I want to flow through our assignment. I'm afraid this video is going to be more than 10 minutes, but guys, I'm doing my bestest. So let's do some labeling. It says that from on number 6, D to F is 8.7. So I'm going to highlight this. This guy right here is 8.7. It says find EG.